I mean, think about it. 500 million tweets every single day. That's insane.
500 million? Wow, that's a lot of cat pictures and political arguments. But seriously, how does Twitter even handle that kind of volume? It's not like they're just throwing it all into one giant database and hoping for the best.
Oh, absolutely not. Imagine the read latency on that thing. No, they've had to build a seriously sophisticated system to deliver those tweets to our timelines in something resembling real time. And that, my friend, is what we're diving into today, the architecture behind Twitter's timeline.
Because if Twitter didn't get this right, well, imagine waiting minutes for your timeline to load, or missing crucial breaking news, or worse, only seeing tweets from 3 days ago. The user experience would be horrendous. It's not just a technical problem, it's a business-critical one. They'd lose users in droves.
Exactly. Think about the cost of failure here. It's not just slow loading times, it's potential misinformation spreading faster than it should. It's a degraded experience for influencers and power users who drive engagement. It's a whole cascade of problems. So, let's talk about the core challenge, the fan-out problem.
The fan-out problem. Okay, explain that like I'm a software engineer who's vaguely heard the term but hasn't had to implement it at scale.
Okay, picture this. Someone you follow, let's say Elon Musk, tweets something. That one tweet needs to be delivered to millions of his followers. That's the fan-out. How do you efficiently fan out that single piece of data to so many people?
So it's not just about storing the tweet, it's about distributing it and quickly. What are the basic approaches?
There are two main schools of thought, push and pull. Push is where, when a tweet is created, Twitter proactively pushes it out to the timelines of all the followers. Pull is where each user's timeline pulls the latest tweets from the people they follow when they open the app.
Okay, I can see the trade-offs already. Push sounds faster for the end user, but must be incredibly resource-intensive for popular accounts. Pull is probably easier to implement initially, but could lead to noticeable delays.
You nailed it. The push approach is often called write-heavy because you're doing a lot of writing to all those timelines every time someone tweets. The pull approach is read-heavy because you're doing a lot of reading from various sources every time someone opens their timeline. Think of it like this. Push is like a newspaper subscription where the paper is delivered to your door. Pull is like going to the newsstand to buy the latest edition.
Okay, that makes sense. So does Twitter use purely push or purely pull? I'm guessing it's more nuanced than that.
Oh, Shrija, you know me too well. It's almost certainly a hybrid approach. For accounts with a smaller number of followers, a push model might be perfectly acceptable. But for those mega influencers, they likely use a combination of push and pull, or even just pull.
But wait, doesn't that mean that some users might see tweets from Elon Musk faster than others? How do you handle that inconsistency?
Ah, that's where caching comes in. Caching is absolutely crucial for handling the sheer scale of Twitter's timeline.
Okay, caching. Everyone knows the basics of caching, but how does Twitter specifically use it in the context of timeline delivery?
Think of it like this. Instead of hitting the database every single time someone opens their timeline, Twitter stores frequently accessed data, like recent tweets from popular accounts, in a cache. This cache is much faster to access than the database, so it significantly reduces latency.
Makes sense. So what kind of caching strategies are we talking about here? In-memory caches like Redis or Memcached? Content delivery networks, CDNs?
Probably both. In-memory caches like Redis are likely used for the most frequently accessed data, the hottest tweets and timelines. CDNs can be used to cache static assets like images and videos embedded in tweets, further reducing the load on Twitter servers. They likely have multiple layers of caching, each with different expiration policies and invalidation strategies.
Okay, so you've got in-memory caches for speed, CDNs for static content, but how do you keep the cache consistent with the database? What happens when a new tweet comes in?
That's the million-dollar question. Pause for effect. There are several strategies, but one common approach is cache invalidation. When a new tweet is created, Twitter invalidates the corresponding entry in the cache, forcing the next request to fetch the latest data from the database and update the cache.
But invalidating the cache too aggressively can lead to cache thrashing, where you're constantly fetching data from the database and negating the benefits of caching.
Exactly. So you need to strike a balance. You might use techniques like time to live, TTL, to expire cache entries after a certain period, or use more sophisticated invalidation strategies based on factors like the popularity of the tweet or the user's activity.
Give me a real-world example. How does Netflix, for instance, use caching in a similar way?
Netflix uses caching extensively to deliver video content to millions of users around the world. They use CDNs to cache video files closer to the user, reducing latency and improving the streaming experience. They also use in-memory caches to store metadata about movies and TV shows, like titles, descriptions, and ratings. When you browse Netflix, you're primarily interacting with cached data.
Okay, that's a good analogy. So we've talked about fan-out and caching. What's the really hard part that most engineers underestimate when building a Twitter-scale timeline?
Here's the crazy part. It's not just about delivering tweets, it's about delivering them in the right order. Think about it. Your timeline isn't just a random jumble of tweets. It's supposed to be chronological, or at least ranked by some relevance algorithm.
Right, you can't just throw tweets at the user and hope they sort it out themselves. Ordering is crucial for the user experience.
And that ordering becomes incredibly complex at scale. You're not just sorting tweets by timestamp, you're factoring in things like the user's interests, the popularity of the tweet, and the relationships between users. You might have to combine multiple data sources and apply complex ranking algorithms in real time.
So it's not just about speed and scale, it's about the complexity of the data and the algorithms you're applying to it.
Precisely. And here's where it gets interesting. The algorithms themselves are constantly evolving. Twitter is always experimenting with new ways to rank tweets and personalize the timeline experience. This means that the system needs to be flexible and adaptable to accommodate these changes.
That sounds like a nightmare to maintain. How do they manage that constant churn?
They likely use microservices architecture, where different components of the timeline system are broken down into independent services. This allows them to deploy changes to one service without affecting the others. They also probably use feature flags to gradually roll out new features and monitor their impact on user engagement.
So it's all about modularity and continuous experimentation. But what about handling failures? What happens when one of those microservices goes down?
That's where resilience engineering comes in. They need to have robust monitoring and alerting systems in place to detect failures quickly. They also need to have mechanisms for automatically recovering from failures, such as redundancy and failover. Think of it like a self-healing system that can adapt to changing conditions.
Okay, that makes sense. So to recap, we've talked about the fan-out problem, caching strategies, and the complexities of ordering and personalization. What's the biggest takeaway for a software engineer listening to this? What should they do differently after hearing this?
3 things. First, understand the trade-offs between push and pull. Don't just blindly choose one approach. Carefully consider the specific requirements of your application and the scale at which you're operating. Second, embrace caching, but be smart about it. Don't just throw a cache in front of your database and call it a day. Think about your caching strategy, your invalidation policies, and your cache eviction algorithms.
And third?
And third, design for complexity. Don't underestimate the challenges of ordering, personalization, and resilience. Build a modular, adaptable system that can evolve over time. Think of your architecture as a living organism, constantly adapting to its environment.
So fan-out, caching, and complexity. Got it.
Exactly. And remember, building a Twitter-scale timeline is not just about solving technical problems. It's about creating a seamless and engaging user experience for millions of people around the world. It's about making the world feel a little bit smaller and a little bit more connected.
So really, it's about making sure the right tweet gets to the right person at the right time.
Precisely. And that, my friend, is the secret sauce of the Twitter timeline.